So what we're going to be looking at is the end of this section, and then we'll get into 10.3 today, where we do some new derivative rules. Let's get quiet now so we can get going on this. I want to first of all review the change of base rule that we did at the very end of class last time. So I want to just kind of go over how that works real quick, because if you know this rule, it'll keep you from having to learn one more derivative rule. Okay, so it works kind of like this. If you had something like log base 7 of 10, okay, something like that. Okay, well, you don't have, your calculator will have a place on it where you can put a base 7, but you don't have to know where that is, because what you can do is you can change this to ln of 10 over ln of 7, or you can go log of 10 over log of 7 like that, okay? I just put this in your calculator, if you brought your calculator with you real quick, so I want to make sure everybody knows how to do that okay. And so if you're going to do the log base 7 of 10, you can just go, and you can use ln or log, so I'm going to go ln 10, and then divide by ln of 7, and then that'll give an answer to that problem. Okay, so that's how you can do a logarithm of any base, like that. All right, so that's what I'm getting. Is that working okay? All right, everybody with me there? Okay. The reason I want to go over the change of base formulas is because we got to learn one more derivative rule in this section, and it has to do with the change of base formula. Okay, so let's go down to this example here, and let me show you how this goes then. Okay, the rule basically goes like this. So let me talk about this rule right here. So I want to see first of all what you all remember. Okay, we're getting to a point now you're starting to learn lots of derivative rules. Okay, do you guys remember what the derivative of ln of x is? What? 1 over x? Is that what you said? Yeah, okay, that's 1 over x. Okay, that's what we worked on last time, and I showed you why that is. Well, it's different if you do the derivative of like log base 7 of x. It's totally different. So let me explain how that goes, and I'll explain why that is. So what it is on this, if you're doing a log of some other base, it's still 1 over x, but there's one difference. You have to say 1 over ln of 7. Okay, and I'll explain why that is in just a minute here. So that's what that rule basically tells us to do, is you got the 1 over x, but you have to add in that natural logarithm of what that base is. Okay, it goes like that. So let me show you why this works the way it does. All right. You can learn the rule and easily just get that derivative done. This is the way I do it because I forget the rule a lot when I'm teaching this. So what I want to do on this is just show you how to do this with the rule. So when you're doing this, you just got to remember two things. First of all, it's 1 over x, regardless of what the base is. But then what you do is it's 1 over ln of 10. See, that base is 10, like that. So it's 1 over ln 10 like that. There's your answer like that. You can write it like that, or you can put it in one fraction and just write it like that. Okay?
So the final answer will be the same as...
No, because ln 10 is going to be some decimal value. So it's not the same as the derivative of ln x. That's just 1 over x. I'm going to explain something on that in just a minute. So that's the only thing that makes it different is if you have that ln of the base. Okay, that's how that goes. Okay? Now I'm going to show you one other thing here. Okay, this is the way I do this. So I want you to write this like this. Okay, let's start by writing log base 10 of x. Let's use the change of base formula. Okay, let's write this as ln of x over ln of 10, like that. Okay, now we're going to do the derivative of this, just knowing the rule that we know. You can get by if you just know that the derivative of ln x is 1 over x. Okay? What kind of thing, what is ln 10? Is that a variable or is that just a number, like a constant? It's constant. It's a value, right? Okay. So what you can do is you could write this as 1 over ln 10 times ln of x. And that's a constant. This part right here, that's just a constant. And remember, when we do a derivative, we just write the constant down and multiply it by the derivative of the function, see? Okay? So now here's how I would do the derivative is like this. Okay, so I would do the derivative of 1 over ln 10 times ln of x like this. Okay, remember the constant just comes out of the derivative, you just write it down. So that would be 1 over ln 10, and we learned what derivative of ln x is. What's that again? 1 over x. There you go. Good. Okay, so same answer, see. Okay, that's why you get that ln in there, is because it comes from the change of base formula. All right, you can learn it either way. I mean, it's easy to learn the formula, but you can also do change of base formula and kind of develop it as you go like that. That's what I do when I forget it, because this is an easy rule to forget. You won't see work with logarithms other than ln x too much in calculus. Okay, and even in economics and stuff, most things are in base e when you're working with it. Okay, is there any question on what I did there so far? Okay, the derivative rule is pretty easy. So let's go to the next page and let's do one more like this, and then I'll just give you one to try to do here. Okay, so when you do this, just do the rule. Okay, 1/4 is a constant, so what do you do with that constant? You just write it down. Okay, so you just write it down. Okay, now when you do the derivative of log base 9 of x, there's only two things you got to remember. It's 1 over x. What's the other thing? 1 over ln 9. There you go. That's it. And you can write your answer that way. I mean, what you do typically is just multiply it all together, put your fraction together, you multiply straight across, so you'd have 1 over 4x ln 9. And that's it. Okay, like that. That's all you do. All right? Okay? If you do change of base, you would go like this. Okay? And you don't have to do it this way. You would have 1/4, but you would change the log base 9 of x to ln of x over ln of 9. I like to do it this way because it's one less rule I got to remember. Okay? So here's what you want to think about. What do you know about 1 over 4 and ln 9? Is that a variable or is that a constant? It's a constant, so you write it down, right? Okay, so that just gets written down. That's what we're used to doing. So you'd have 1 over 4 ln 9. Well, then what's the derivative of ln x? That's 1 over x. That's the only thing you got to remember, see? So you get the same answer. It's in a little bit different order, but that doesn't make any difference. Okay, so that's the idea, all right? Okay, are you guys with me on that, okay? Okay, all right. Okay, now I'm going to go ahead and do the exponential. I'll have you do a few problems after we do this, but I want to just get you through that. Those are your two choices on how you're going to do that derivative, okay? Okay, the next thing's pretty similar, and what you want to do on this is we've learned this rule, okay? I hope you got this one down. What's the derivative of e to the x? E to the x. Oh, look at that. In unison. We all got that one down, okay? That one pops up all the time. That's one of the easiest derivative rules to remember, so that's good. So it's going to be very similar to the last kind of thing we did. What happens is if you do the derivative of something other than e, e's like an irrational number, 2.7 approximately. Like if I did 3 to the x, it's slightly different. It's still itself. It's still that, but there's more. The other thing you got to do is you got to do times the ln of the 3. It's not divided by like the logarithm, it's times. Okay, that's the way that works out, is like that. That's what you always do if that base is anything other than e. That's how that goes. Okay, I'm not going to derive that one. That's a little bit more complicated to derive, but I do want to show you guys one other thing on this and see if this makes sense to you. You've already learned that derivative of e to the x is e to the x, but you could do this way. You could use this rule. It's itself times ln of e. But what is ln e? Have you got that down? 1, okay, right? Okay, so that's e to the x times 1, so it's e to the x. So that rule always works. It's just that ln of e is 1. That's why you learn derivative of e to the x is e to the x. Does that make sense to you? Okay. All right. So let's do some derivatives. These things are not going to pop up a lot in this class, but they will here and there just a little bit. So let's do some of these derivatives here. I'm going to do the first two and then maybe let you try that last one there and see if you got this all put together or not. Okay. All right. So what you know on this is you're learning the new rules on this. Okay. So think of it this way. When you're doing 2 to the x, think of it in words. Itself times ln of 2, like that. Think of these rules in words. So that would be this. That takes care of that. Okay, that's the new rule. Okay, what's the derivative of e to the x? E to the x. Okay, I've got that one down. What's the derivative of ln x? 1 over x. Good. Problem done. Okay, like that. So they're easy to do. You don't get any messy algebras just knowing the rule. Okay? Okay, next one. What do you do at the 1/3? Write it down. Okay, that's a constant. Okay, now when you do the derivative of 3 to the x, two things. Itself times ln of the base. Okay, think of it that way. So you just do itself times ln of 3, like that. Okay, or am I done? Well, you could do this. You could just write this as 3 to the x times ln 3 over 3, like that. I got a bunch of 3's. Do any of those 3's cancel out? Ah, good. One person shaking his head no. I see stuff like this all the time from students. A lot of times I'll see students want to cross out 3's and stuff like that. Okay, this is the whole thing. ln 3 is like the entire number. You can't just break up part of it. Same thing with 3 to the x. It's an entire expression, so you can't break up part of it. So that would be how you'd write the answer, is like that. Okay, problem done. Okay, all right. Go ahead and I want to see what you guys could do on this one. And just, you can do it all in your head. And what I'm going to do is write down the two new rules that we learned. We learned that the derivative of log base b of x is 1 over x times 1 over ln of b. That's how you're going to do those two logarithms. And then we learned that the derivative of b to the x is itself times ln of b, like that. That's what we learned, okay? So just see if you can process that and put that together. I'll walk around just on this one and see kind of what your thought process is, but you're applying those rules primarily on that. Let's see what we get. Once you get the rules down on these, are pretty easy to do. Be careful about log x, because that's, you know what the base is if it says log x? 10. There you go. Okay. That's one of the things I want to make sure that you got. Yeah, that should be good. Okay. Hey, I thought you were a new student starting to
I'm looking a little lost.
Okay, that's good. Now that one right there, that's a log base 10. So if you did that one right, that's 1 over x ln 2, but that's a base 10, so you do it the same way. Anytime you have log, that's a base 10. Yeah, but it's also got the 1 over x in it too. There you go. That's good. That's what I'm looking for. Okay. You got it? You got your notes?
I didn't print it up.
Okay.
So I got
Oh, okay.
I just printed up the top.
Oh, okay. Yeah, we're gonna do today. We're gonna go 10-3 mostly.
Oh,
As long as you can go out there and now that you need to do. Go ahead and get that done because we're getting ready to start on that. That's it. That's still the same thing. It's 1 over x ln 10 though. Okay. See, the derivative of both of those logs is done the same way. Okay. It's the same concept on that. Okay, got the first one right now. So you just got to understand that's log base 10.
Yeah.
So if you get the derivative of log 2, it's the same concept. That's good right there. Yeah, if you write the answer like that, that's good. Okay, it's itself times ln of what that base is. So you always, on these things, you always end up with that ln on each part on them. That one's off a little bit. See, you did that part right. This is done the same way. That's log base 10 of x, so it's 1 over x ln 10. So that's correct for this. The next one's just 1 over x ln 10. You forgot to put the x on that log, and that's what kind of messed you up a little bit. See, that's good. Okay, that's good. You got it okay? Have you got an ln 10? Yeah, you're okay. All right, very good. Okay, outstanding. Okay, so this part right here is log base 10 of x, like this. So it's like this. That's the part some of you slept up on. This is 1 over x, ln 2. The next one is almost the same idea, 1 over x, ln 10. Okay, and then the next one is itself times ln of 10. That's it. And you can write the answer like that, you're done. Okay? All right? That's all there is to it. Anybody have any questions about that? Okay? That is going to show up a little bit, but not as much as ln. ln will show up all over the place in the rest of this class.